Now we're going to look at piecewise functions, and really what piecewise functions mean. We're also going to look at what's continuous, discontinuous, and discrete. A piecewise function is a function defined by multiple subfunctions. How I really like to look at this, though, is that a piecewise function is made up of pieces of functions. Okay, so that it's pieces of other functions. Now, a function is a segment that every input or every x has one unique output or y. Okay, this becomes very, very important later on in mathematics. Now, we generally relate to, a lot of students relate to functions as if it passes the vertical line test. Okay. And then, like I said, we're going to look at whether a function is continuous, discontinuous, or discrete, or if pieces of it are continuous or discontinuous or discrete. Okay, so to do that, what I'd really like to do is look at this particular function. If we look at this one, we have, this is at -3, 0, and this is at 0, 3, this point. This point here is at 1, 0, and I can pick any other point, and I'll just say that's at 3, 2. Now this will go infinitely far in the positive direction. What a piecewise function is a function that is of different functions. So in this case, I've got a linear function and a second linear function. This is just a piece of a line. This is going to be a vector. It stops and goes. And so what I've got to do is I'm going to have two pieces, therefore I'm going to have two functions. This will be function A, and this one will be B. Now, to do this, the easiest way to start is to look and see what is my domain for A. It goes from -3 to 0. Put my x in there, and I have it less than 0 and less than or equal to 3. So my first function A is going to exist anywhere that x is between -3 and 0. My second function goes from 1 to infinity. Again, I put my x, my less than signs, so x is going to always be greater than 1. Now, how this is actually working, and you're going, well, why are we putting the x over here? This here is going to be what happens to y when x is this. And so when I look at this first function here, I can tell you that it's got a step of 1, it's got a slope of 1, 1 over 1, and that the y-intercept is at 3. So I know that my function is x, because it would be 1x, mx, plus my y-intercept is 3. So in this case, y equals mx plus 3. And so I'll use a comma to stand for when. So this y will equal x plus 3 anytime x is between -3 and 0. Now I've got to look at the b, and it's the same thing. I've got, if I draw up here, I know that my y-intercept's at 1. My step is a -1. I'm going down 1 over 1. So now I have a negative x plus 1. My y-intercept would be at 1 if it went that far, but it doesn't. It starts at 1. And so my function will equal to negative x plus 1 when x is greater than 1. So if x is 2, I can say if my function at 2, I can go in here and go, okay, when x is 2, y is equal to negative 1. I'm sorry, yes, y is equal to negative 1. So f of 2 would equal negative 1.